everyone. My name is Lisa. I'm a data scientist at Airbnb. This is Lou. He's a software engineer on Airbnb, and we both work on the search and discovery team. We're really excited to be here. We're going to talk about some of the ways that we use Hadoop technologies to inspire travel at Airbnb. So I'm going to start off with just kind of a background on how search at Airbnb works, like what's the searching process for a potential guest. Lou's going to talk about how we built a specific product called Discovery to inspire travel. This is a data-driven product, and he's going to go behind the scenes and talk about how we use Hadoop and Spark technologies to process large amounts of data to make this product. And then I'm going to finish off by describing how we measure success, specifically for this product, but just in general at Airbnb using A/B testing. Okay, so Airbnb was founded in 2008. It is a marketplace that enables guests who are looking for a place to stay with hosts who have room to spare. So in 2009, we went global, and this just kind of shows you how we grew as a company throughout the years. Let's see. So we're expanding. Each of these dots represents a certain number of listings. So let's see. And now in 2015, we have 1.2 million active listings all over the world. We're in 34,000 cities in 191 countries. I'm especially happy to say this because I've done a lot of presentations with this kind of slide, and the right number has always said 190. But in April of this year, we launched in Cuba, so now we are in 191 countries. So I assume that many of you are traveling from other cities to attend this conference. Some of you might even have booked a listing at Airbnb. For those of you who haven't, this is kind of what the search process looks like for a potential traveler. So you go onto our website, airbnb.com. You enter in where you would like to go, who you're traveling with, what your check-in and check-out dates are. From there, it takes you to our search page, which lists all of the potential listings that are available given your search criteria. You can select one or more that you're interested in and click on them to find the listing page, which tells you more about the listing. You can browse the beautiful photos, many of which are professionally taken, learn more about the listing, look at the amenities that it offers, read reviews from other guests who've stayed with this host, and learn more about the host. If you have more questions or if you would like to make a booking, you can contact the host, and hopefully they will answer your questions and you will book with them. So this process works really well. Come on. Okay, this process works really well if you know that you're going to San Jose. But what if you don't know where you want to go yet? A lot of people just have this notion that they like to take a vacation or they like to get out for the weekend, but they don't know exactly where you want to go. So currently, our search page works the same for everyone. So someone who knows that they want to go to Monterey this weekend is going to have the exact same search experience as someone who says, I just want to go somewhere in California, but I don't know where. Except in the second case, the bounding box for the search is going to be larger. It'll cover all of California. But does this really make sense? Does someone who enters in a query as broad as California, should they have the same experience as someone who enters in a query for Monterey? Our data shows, Our data shows that queries broader than the search, than the city level, so state, country, or even continent, they comprise 10 to 15% of our daily search queries. And these queries are less likely to convert in the next month by 25 to 30%. So some of this is, of course, correlative. Somebody who's searching for California probably has less intent to make a booking than someone who searches for something as specific as Monterey. But we still thought that there should be a different experience for these travelers who don't know where they want to go yet. So Lou is going to talk about our product discovery. This is not working. Okay. So
Hi, everyone. I'm Lou. As Lisa mentioned before, I'm an engineer working in the search and discovery team at Airbnb, and I'll talk a little bit about the discovery products that we've built. Sorry, guys. Okay. So first, I'll talk a little bit about the product timeline. So a little over a year ago, we had something called a rebrand, where we came up with a new logo, we completely redesigned our site, and came up with kind of a new company mission, or redefined our company mission. And in the process, we actually, our homepage changed quite a bit. So on the left, we see the homepage from about a year ago. On the right, we saw the homepage like right after the rebrand. And we ended up launching a lot of location-based recommendations on the site. So next. So depending on where you are in the world, you would see something different. So in Paris, you would see things that are more relevant to people in Paris. New York, more things on the East Coast. San Francisco, you would see things near San Francisco. Next. Sorry. So if we dive deeper, you guys probably couldn't see that clearly, but Paris, you see things near Paris. Next. New York, we'd see things on the East Coast again. San Francisco, we see things that if you guys are from San Francisco, you're probably familiar with this. Cool, so from there, what we found before was if you click on one of those cards, you go straight to the search page. It still doesn't provide too much context about why we're showing you the listings that, why we're recommending you that location doesn't give you that much of a flavor of what the location is like. And we found all of that was kind of driven by the data. And what we found was we wanted to provide people more context when they're actually looking for a location to stay. So for those low intent users, we want to provide more context. So from there, next. From there, we launched something called a weekend destinations page, where essentially we had a call out on the homepage that essentially showed weekend destinations near you. So it was a little bit more focused, and if you clicked on one of those destinations, you would, next. You would go to a new collection of locations page. So instead of going to the search page that lacks context, you would see collections of locations, and we provide much more information about why we're recommending a listing, or why we're recommending the location. So next. If you dive a little bit deeper, look a little bit closely, you see like kind of a lot more context about why we're showing something. We have pictures, we have like a why visit section, a map, and some weather information, also information about your social connection. And Lisa later will talk a little bit about how this experiment turned out and the results from it, but I'll keep going with this part. Cool, so now that I kind of had a brief overview of the product, I'll talk a little bit about how we generated each part of the recommendations. As I mentioned before, if you're in different parts of the world, you see different things. And the way we generate all of this data was we looked at our travel patterns around the world. So we ingest tons of logs every day. We have a lot of bookings, so we're essentially able to have a pretty macro view of worldwide travel patterns, which is pretty exciting. So this feed is actually built completely by the data that we have. For the way we select the locations, essentially we do a lot of co-occurrence analysis based off of where you are in the world, where the origin destination and where people from where you are around the world travel to. So that's how we select the locations. We did a lot of co-occurrence analysis and did a lot of and evaluated that quite a bit. But what's interesting is we also, in that process, we were also able to discover a lot of interesting things about locations. So we wanted to provide more context about why they should go to a location. And we actually came up with these attribute cards that we found by essentially doing analysis over our reviews and descriptions. Next. Cool, so you can actually tell a lot about a location from listing descriptions and reviews. You can't see this, but essentially this listing is called Charming Flat Near the Seaside. And next, if we look a little bit closely, you can actually tell a lot about the location. Just from the description, it mentions the word beach a lot. From there, next, we can also see that a lot of the reviews, they mention the word beach, shops, old town museums, things that really get a feel of what the location is really like. Next. So the way we actually ended up coming up with a lot of these attributes that we use to classify a location. So the way we found these attributes are essentially we looked at words that that describe a location pretty well. So we essentially looked for words that had a bimodal distribution in the location. So on the left-hand side, we see a lot of locations don't mention the word beach at all. On the right, we see there's some locations that actually mention the word beach quite a bit. Next. So the way we essentially found that is we ended up tagging around, we ended up identifying around 250 words that we felt are pretty good at characterizing a location, and we manually curated that down to a list of 150, and we have a reasonably good tags for all of those, for the cities that we're in now, that we have reviews and descriptions for. So this is kind of something interesting. It's a heat map of all the listings in the world that mention the word beach. As you can see, it's focused kind of near the ocean areas / near the water, which means it's kind of interesting. It's doing a pretty good job. On the right, we have nightlife, and those are kind of more in cities that have a lot of nightlife, which makes sense because nightlife is typically concentrated in cities. Next, we did a lot of interesting work around essentially finding which parts of the cities are good for what. So on the left, we see shopping in San Francisco. On the right, we see all of the listings in San Francisco. And what we found is if you kind of look a little bit closely, you can see the Union Square area has a higher concentration of listings in San Francisco that mention shopping. Next. So we did a little bit more work in terms of cleaning that data up. And we essentially scored the listings based off of its nearest neighbors. And what we found is shopping, and we found essentially we're able to identify which geographical regions were really good for shopping. So you can see the Union Square area had, those are the top things that, top listings that we think are good for shopping, and and on the right we also have hiking as well. So hiking, you have a lot of listings in the green, which kind of makes it seem like it's working because you typically hike outdoors. Next. Cool, so now that I kind of gave a brief overview of the product, I'll go a little bit behind the scenes about our Hadoop technologies that we use. And then Lisa later will kind of talk about experiment analysis of the products that we've built. So next. This is kind of what the Airbnb data scale is like. We're processing over 1 billion events every single day. And by events, I mean essentially core user actions, whether or not they click on something, whether or not they hover something. And this really helps us give a lot of introspection about how, how our site is doing and what features or how people are using features and how we can better improve the user experience for both the guest and the host. We're ingesting around 1 terabyte of raw information each day from database dumps and event logs. And the total data, including the raw information, the processed information, is over 2 petabytes now. And to kind of analyze all this data, obviously it's a lot of data. We have around 150 data scientists and engineers working on analyzing data and also automating the process of, next. Cool. Right, so this is kind of the data lifecycle at Airbnb. So I'll give a brief overview how we ingest events and what kind of technologies we use to process them. So Airbnb.com, every day we have DB snapshots that we dump to HDFS. From there, we also have Airbnb.com also has user events logs. We log everything from the back end, but we also have logging on the front-end clients, so on your website, and also mobile logging as well. From there, these user events are ingested into Kafka. They're dumped both to S3 and HDFS. And on HDFS, we do a lot of the heavy lifting, the processing of this data. So we use this logging, or we do data processing on both the data behavior and also influences a lot of the products like search, price prediction as well. From there, this batch process data store is dumped into some things where we can actually serve the data. So like Redis, S3, we also built a bulk upload read-only key value store in-house that we use to process a lot of this data as well. So that's great for, and all of that batch process data feeds back into Airbnb.com. So we use a lot of that data in production. But from there, we also need so this is helpful for things that we kind of like are okay with the delay of. But we also have another store for more real-time events. So things that we want, like if a user takes actions on certain events, we want to immediately like take action on. For example, if we want to do any type of personalization or show users like the recently viewed listings or something, we have a real-time event store as well for that. And that's queryable, and it goes back to Airbnb.com as well. Cool. Yeah, so that's kind of a high-level overview of what the data lifecycle looks like at Airbnb. We also use a few data tools as well. These are a few things that we recently open sourced, and it's been immensely helpful for us. So we have something called Airflow and AirPal, and I'll talk a little bit about each of those. Cool, so Airflow is a system to programmatically author, schedule, monitor, and debug data pipelines. It comes with a easy-to-use UI. It helps us essentially debug a lot of our jobs, and it has a lot of nice visualizations to kind of help us understand what's going on. If you guys are interested about hearing about Airflow, Max from Airbnb is giving a talk called Data Pipeline Powered by Airflow, which is happening Wednesday, 11:15 a.m. So you guys should go to that. It'll be an awesome talk. Cool, so another thing that we use is called AirPal. It's a web-based query execution tool which leverages Facebook's PrestoDB to make authoring queries and retrieving results simple for users. We have probably over 500 tables in our default namespace in Hive. It's pretty messy. It's kind of hard to go through. And we found this tool is really helpful to like kind of quickly do ad hoc queries. It makes finding tables easy. It makes like recognizing, finding the fields really easy, getting previews, and also does things like saving. You can save your query to it. It'll remember it, and you can also download the result of a query as a CSV. And these things are all immensely useful for us to do data processing Airbnb. So this is something that's pretty exciting to check out as well. We've open sourced this. Cool. Next. So another thing that we have picked up in the past year and a half. We used to do a lot of Hive. We still do, but we've also picked up a few other technologies like cascading and Spark. And I'll talk a little bit about why we kind of chose to start doing that. Next. So why cascading? Lessons learned. What we found in the Hive world was we had a lot of these scripts, and we didn't have a lot of, we weren't able to reuse all of them. So what cascading gave us, it's a Java language, so it gave us functions. You can have a lot of reusable and testable components. So that was really great for us. That's something we wanted. And yeah, so, and also, it's also very well documented, robust, and as our data size grows, automatically doing parallel execution and complex workflows was pretty important for us to get our jobs finishing. Cool, so a few things that we built out of using cascading that a few reusable components are, one thing that we found in the Hive world was essentially a lot of what we were doing is a lot of just like joining. If you guys have used Hive before, you guys definitely are familiar with that. What we did with cascading is we built an aggregated user data. So essentially, it's it's keyed by user ID, and the result is an aggregated user data thrift object, which we found to be really useful in things like discovery and demand prediction as well. So essentially, we took all of our core user actions, our users, listings, bookings, inquiries, listing views, searches, things that we care about, the user location, and we aggregated into one giant object that we can do processing on, and this made a lot of our data jobs very easy. Since we really care about listings on Airbnb as well, we also built something similar for our listing data, and we aggregated it, the descriptions, listing reviews, stuff like that. Cool, so now that I've given a brief overview of kind of how we use data at Airbnb and kind of the overall high-level view, Lisa's going to talk a little bit about experimentation.
All right, so Lou talked about our data stack and how that was used to power the discovery product. I'm going to talk about the third piece of the product cycle, which is how we measure success. So we do this through something that most of you should be familiar with. Called A/B testing or experimentation. So let's say we launch a feature and we keep track of a certain metric. In the case of Airbnb, the metric that we care most about is bookings because that's directly tied to our revenue. But for other companies, it might be click-throughs or monthly active users. So basically, it's something that you monitor very closely, and then let's say we launch a feature in May, and we see that bookings increase in the subsequent months. So we want to know, did the feature that we launched in May cause this jump in bookings, and how much of it did it help? So it's hard to know that without knowing what the world looks like without the feature, like what the world would have looked like without the feature. For example, at Airbnb, May is the start of our travel season, so our booking volume naturally increases every year around this time. We also could have launched a major campaign at this time that was causing these bookings, so it's hard to isolate these things. So what we really want to know is what the world looked like without the feature and what the world looked like with the feature. It could have turned out that bookings would have increased even more had we not launched this feature. So this allows us to really quantify the effect of a product. We do this everywhere on our site, or for all of our products. At any given time, we have over 100 experiments that are running at different parts of our website. So if you go onto our website either as a host, as a guest, anything, chances are you are probably in one or more of our experiments. So I'm going to talk a little bit about how A/B testing is a little bit different at Airbnb, or some of the nuances of A/B testing at Airbnb. So one issue is that we always want to increase bookings. That's our main metric that we keep track of. But the search to booking process actually has several stages along the way. So as I showed earlier on in this talk, so someone who's searching, by the time they decide to contact a listing, they must contact the host. The host then must accept that request, and then the guest has to decide, okay, this is great, I want to actually book it. So there's a few steps along this way, and every time we do an A/B test, we monitor closely the different stages of this funnel. Another issue is that this process kind of takes a long time. So on average, from the time that somebody first starts searching for a listing to when they actually book it, it takes about a week and a half. This makes it a little bit difficult to run short time experiments. So to get a really accurate view on how a feature improves bookings, we have to let experiments run for about 2 weeks usually. Another issue is that users don't have to be logged in when they search or browse listings. In fact, we don't prompt or force users to log in to do anything unless they're ready to actually contact the host. So this means that if we run an A/B test, somebody who's browsing our website at work on their work computer might get a completely different search experience or a different variant of the feature than if they were browsing their home computer at home and when they actually book. So if somebody has been on multiple devices, they are likely to have been in both treatment and control, and if they make that booking, it's hard for us to attribute that booking to a specific product. So we call these mixed group users, and it makes A/B testing quite difficult for us, or any website that doesn't automatically force a user to be logged in to access their features. So this is a cumulative distribution of the fraction of visitors who have been in both treatment and control for a 50-50 A/B test. And we see that after 1 month, after 1 month, about 3% of all visitors to our website have been in both treatment and control. This number goes up to about 5% after 6 months, which is longer than we'd ever run an A/B test for. So this doesn't seem like that big of an issue, 3%, but the issue is that these visitors who have switched devices, they tend to be the most active users and the most likely to make a booking. So this shows, this compares all visitors to just visitors who have made a booking. And you can see that after 1 month, the 3% of mixed group visitors have made about a quarter of the bookings on our site. And after 6 months, this goes up to almost half. So if we do something very naive, like just throw out all users or all visitors who've seen both treatment and control, we're actually taking away the most active users in our experiment analysis. There's an even more subtle issue, and this happens when you run experiments with unequal treatment and control sizes. So this is something that's done all the time because maybe you don't want to launch a feature to half of your user base. You only want to test it on a very small sample at first. So doing this incorrectly will actually bias your experiment. So to understand this a little bit more, let's take a 50-50 experiment, equal treatment control sizes. In this case, if I started out in group A and I switch to a different device, I will have the same probability of switching to a different group as if I had started in group B. So if we do something like taking out all of these mixed group users, we don't really have any bias here. But in the second case, if we have a 25-75 experiment, if I started in group A and I switch to a different device, now I am 3 times as likely to switch to group B on this new device. So this means that the smaller group will always contain the higher share of mixed group visitors. And if we take out all of these users, at the end of the day, you will always bias your experiment against the smaller group because we know that these mixed group users are more active. So the way that we actually found these issues was that we ran something called an AA test, which is like a dummy test. So it's basically just an A/B test where the treatment is the same as the control. So if everything is set up properly and you keep track of your metrics, you shouldn't see anything that's different. Like everything should be neutral. And if something is not neutral, that means there's something wrong with your experiment setup. So this is very easy to do because you're not actually launching anything. You can let it run for long periods of time, like we let ours run for over a year, and then we could go back and see how much of an issue this had. And I'm not going to talk about exactly what we did to combat the mixed group problem, but if you guys have questions, you can talk to me afterwards. So now I'm going to talk about how we used A/B tests to measure the effect of discovery. So we actually ran this as a 3-way test. So we had a control where the home page had no discovery content at all. It was just a search bar with a few other things. Then we ran 2 variants of discovery. They looked identical from the home page. After this header, you have these location personalized cards inspiring you to travel to these different places, depending on where you're from. In one variant, clicking on one of these cards takes you directly to the search page. And in the other variant, clicking on one of these cards takes you to these weekend getaway pages that Lou talked about earlier. Okay, so setting this experiment up this way allowed us to do a couple of things. We were, one, able to measure the effect of having these discoveries on the home page. So this was comparing the treatment against, or comparing the control against the 2 treatments, which looked identical on the home page. And doing it this way, we saw that having discovery content on the home page reduced the bounce rate on our homepage by 5%. This was actually quite significant because if you saw on the previous slides, all those cards were below the fold. So like anything below the fold is really hard to get an increase or to get a decrease in bounce rate. So this was quite significant for us. And by comparing the 2 treatment groups against each other, we were able to measure specifically the impact of the weekend page for those people who clicked on one of the cards. And we saw that out of visitors who clicked on one of these cards below the fold, they were 3.5% more likely to make a booking with us. So that was great. So as I mentioned earlier, we are running over 100 experiments at the same time, and there are not enough data scientists or analysts or engineers to kind of keep track of all of them and see how things are going. So what we've done to enable experimentation to scale at our company is that we've created a reporting framework called we call it the Experiment Reporting Framework, yeah, ERF. And so basically what this looks at, like on the outside, is it's a dashboard for all of our different experiments. It's a centralized location where PMs, engineers, data scientists can get a daily snapshot of how a specific experiment is going. So it's really easy for engineers to set this up. They can add whatever metrics they want, even define new ones if they don't already exist. And every day it'll kind of do the experiment analysis up until that point. It'll compare treatment and control, look at the difference in means, and it'll also look at the p-value. So one thing that we've done that has been really great is, so if you think about it, p-values are normally reported at a 95% confidence interval, so that means that there's a 5% or less chance of this difference having occurred just by chance. So if you have 20 metrics that you're looking at all at once, which we often do, sometimes even more, even if the experiment is neutral, at any given time, chances are one of the metrics is going to show up as being significant. So to prevent these false negatives from happening, what we do is we have plotted out how the p-value and the difference in means has changed over time. And you can see, for example, this last column, which is revenue, it started out, for a couple of days, it actually dipped below significance. So, but as time continued, it lost its significance and now it's neutral. Versus something like bookings, where you see it's been steadily significant over time. So plotting the numbers out in this way has allowed for fewer false negatives and for our PMs to really understand what's going on with these numbers. So just to call out to such a framework, it's really easy to set up. We can define custom metrics. We get daily updates. It allows for statistical robustness. And most importantly, it really standardizes the experiments across different teams, because the growth team will set their experiments up the same way as the search team does. And it really enables a culture of experimentation within our company, which has been great. So that's kind of about it. So if there's kind of a takeaway that Lou and I have here, is that all of our products, especially our inspirational products, they are a mixture of data, product design, and experimentation. They kind of all go in hand to create great products. So today we talked about how we made Discovery, which is a data-powered product aimed at inspiring travel. We talked about our data stack that allows us to process large amounts of data, and how we measure our success through A/B testing. So thank you all for being here. If any of this sounded interesting at all, like any part of this talk, you should go onto our engineering website, nerds.airbnb.com. You can read blog posts, learn more about the culture at Airbnb. The open source software that Lou mentioned is also up there if you want to play with it yourself. And we are hiring like crazy for engineers, data scientists, analysts, all over the board. You can send us an email to come talk to us afterwards. You can follow me on Twitter, all this good stuff. So thank you for being here. It's great.